let's talk about limits. The limit of a function is a very important concept in physics, in mathematics, in engineering. Suppose we have, let's say, if we want to take the limit, um, want to take the limit of this function. In this case, you know that w we said is related to z in this form. So what we say w is a function of z, which is correct. Then, how do we take the limit of this function? When z is going towards a particular z number, that means anytime you see z, I've told you, anytime you see this z, whether it's z of 0, it means x plus I y. Keep it at the back of your head. If you don't keep it at the back of your head, you will miss it out. So this z here is x plus iy. This one here is x0 plus iy0. What is the meaning of this? This small thing that is here is written like, this small thing that you see here is x plus iy going to x naught, okay, plus I y naught. That is just what we're saying. Initial. We're going to see it. Then we say as z goes to z naught is a number L such that this parameter can be made as small, okay, can be made as small as we wish to make it. So how do we do? Well, when we say we're taking the limit, we're taking the limit either towards a particular number. Say we're taking this function is going towards a particular number. It can be significantly a small number, or it can be significantly a large number. We say this limit, this z, it can be going towards a very big number, but how does it behave when it gets to that big number, or how does it behave when it gets to that small number? Okay, but what we are doing here is that if we're taking a limit, we're saying the limit in such a way that that number minus the point we're saying should be very, very small. In some cases, let's take for example, we have this, the one we have just done. What will be the limit? The limit of this function is what? If we say take the limit of this function as z tends to I, as z tends to I, it means that anywhere you see z, you put I. In this case, if we say as z tends to I, it is just saying that z tends to what? 0x, that is 0 plus I. That is the meaning. In this case, y is 1. That is what is happening. That is why if you put it here, any term that, you know, this one was supposed to be x plus iy, all this square, minus x plus iy. So if you put 0 here, you only get what? I square. So that is why we have I square minus I, because the x component of it is 0. That is what we're saying. As z goes to I, what is the function? As z goes to I, we're going to get this function. But now, there is a functional, or there is a fundamental difference from function of real variables, okay? There, we could approach a point on a curve, either from the left or from the right when considering a limit at such point. But in the case of the complex function, we are allowed to approach that point, which we are saying the point is z0, along any path. It must not be from left or right. in the real world, we always approach it, say, okay, the limit as it move from the negative side or the limit as it move from the positive side. But in case of complex function, we approach it from path. It can be from horizontal, vertical, whatever. Okay. So along any path in the z plane. So we require mainly the what? This distance to decrease to zero. This distance which we are going to see to decrease to zero. Now let's say, for example, this is a problem I want us to look at. Now suppose we want to find the limit of this function. Now we say as what? Z goes to 2 plus I. Along each path, how many paths are there? We have A, B, C. What is the A? This is part A. The first thing you need to know, this limit is going towards this direction. You can see from the arrow, this one also is going towards this direction, and this one is going towards this direction. What is the meaning of this? It means that it is good. This is, if you look at this is X, this is Y. In this case, Y is 1. In this case, X is what? 2. For example, if you look at this line that is going is this 2x plus, this is x, this is 2 and 1. Okay, this is just like x and y. Look at this point here. This is x, this is y. So this point here is what? 2x plus, this is 2 plus what? I. Is that clear? This point here. So this line is moving like this based on a particular parameter which we don't know. We can call that parameter k. Because at this point, as the k is increasing, this line is increasing. As the k is decreasing, this line is going like that, right? So this part, there must be a function called k. Then if you look at this part here is a function. This one only has something to do with what? In this case, x is 2, y is what? Y is 0. Now look at this side too. Look at this path. This is path A. This path A, y is what? 1. X is equal to what? 0. Anytime I give you a problem, like this one now, I've plotted a curve for you. Anytime I give you a problem, you must plot it yourself. What do you use in plotting is this. This alone has brought out all these plots you see. Right? This is saying that X is standing alone, so it's coming to us like this too. This one is saying that Y is standing at 1. It goes like that. It's a constant. And then the combination of it will give you this. Let's take, for example, let me say Z. All of us to plot 1 when we have, let's say, 1 plus, let me see, 5 I. Oh yeah, let's plot it and see. And this Y is coming like that. And then what is our X? Our X also is going like that. And then this is the point we're looking for. So you take a straight line. What is this point now? This point now. So in this case, this will be our A. This will be our B. All of them are coming like this. And then this is our what? C. Is that clear? We have said that X is what? X is 2. Y here is equal to 1. Then here, okay, everything about this point now. This is part A, this is part B, this is part C. So this is what you're gonna do.
Sir, in the question,
Are you
sir,
seeing
the
my this?
question states,
Are you seeing what I'm doing?
yes, sir.
Now it says, suppose I ask you to find the limit of this function. Find the limit of this function as s goes to this. I'll stop here. You are the one to say, okay, for us to get a limit as s, you are going to test it along path A, path B, path C. The good news is that if you test it along path A, path B, and path C, all your answer must be the same. If you see the answer here is the same, along path B, A is 1 plus this, along part B is the same, along the other part is the same. If you do it and you make error, you are wrong. So the most important thing is understand what I'm going to do here, because if you miss it, you will not be able to get it. That person who is,
So,
please mute your phone now.
so I'm trying to say something.
Yeah, say the thing you want to say. Let me go. Let me move.
So in the question, it states that y is I and not one, sir.
In the equation, it says y is 1, I. Are you with me?
As s tends to
Eh?
as
No,
s tends to two
question,
plus
sir.
I.
Please. Yeah, I said just understand me. For that 2 plus I, I'm the one who pluck out 1 there.
Okay, sir.
I'm the one who pluck it out. Y can never be, I've always told you now, see, Z,
IY.
yeah, Z is always equal to X plus I1 plus IY. So
Understood,
if I
sir.
say Z is equal to, I've just done one now, 3 plus 4I. I said X here is 3, Y here is 4.
Understood, sir.
One thing you have to look here is that, you see, now this is what they ask you to do, but you are looking along your path. This is, I said again here, if you look at this is X is what? 2, Y is 1. Is that clear?
Yes, sir. It's clear, sir.
Correct. Now, for you to go about it, you must, the section you are looking for example, we're saying that look along the path of X. You're going to like close this part with the value. Like here now, along X, 2 is just a number. So you will put X plus I because it's going along X. Now, if it is going along Y, you remember, if it's going along, you don't touch that point where it is. You see, now let's say it's going along Y. If it is going along Y, it will be along X. You leave this one, you leave Y, you touch X. If it is along Y, you leave X and touch Y. That is how you do it. That's why I say it's a small trick you have to find, you have to understand it. I'll say it again. Along X, okay, you remember there is 2 here, there is I here. So what do? You replace this 2 by X. You are not going to say 2X. Then if it is along Y, right, this one you don't touch it. It is this one that you replace. Along X is this one that you replace. Along Y is this one that you replace. Is that clear? Along X, you don't touch your Y. You only replace X. Along Y, you don't touch your X. You only replace Y. Then along the C section, it is just the K factor. So that is the first thing you need to know. Because we're looking at any value of X. So along this part, this is the key point that you must know. Is coming from here. If that is clear, then you have finished this problem. Okay?
It's clear, sir.
It's clear.
Yes, it's clear, sir.
If it's clear, you have finished the problem. So in that case, now you do your f of that point, f of the point where you're taking the limit. So f of what? x plus I. So anywhere you see x, anywhere you see z, you put x plus I. Anywhere you see z, you put x plus I. So in that case, you put x plus I here minus x plus I here, you open it, you do just as we did before, you take the real and the imaginary part, you keep it together. That is what happened. So when you do the real and the imaginary part, this is the real part and this is the imaginary part. So x is equal to 2, y is equal to 1. So you replace everything here. Now you see that this has nothing to do with y because your function is just a function of x throughout. So yeah, what is x? Because you are moving towards the x, any x direction, right? So you know that this thing now is, you replace it with what? You replace it with x plus I, right? In this case, there is no y. Your y here is 1, right? So there is no So when you open all this, you're going to get everything only in a function of x. And in this your situation here, they say find it in this direction. So in this case, your x is 2. So you replace it when x is equal to 2, the limit now becomes what? The limit of this becomes, you put it everywhere here. So when you put 2 here, 2 here, 2 here, and this, you're going to get this value. Now, the same thing happened in case I set it again. Now, along y, any y, what do? You don't touch, but you touch the y. So in this case now, you put y here. So you see 2 plus y, right? 2 plus yi. You don't touch these two. You put your yi. Such that you do the same thing. In this case now, you are going to have, instead of x plus I, now you're talking in terms of the y direction. Because you're moving towards the y direction. Okay, if your as z goes to this, what will be your y? Y is 1. So the limit now will be, anywhere you see y, you put 1. Anywhere you see y, you put 1. At the end of the day, you still have the same answer like this. Is that clear? Now the same thing now to go
Yes,
to this
please.
part. Okay, it was what? 2 plus I. Now this one now is either reducing or increasing by a function k, by a factor k, where k is the real number. So you put the factor k there. Now when you put the factor k, then you also do the same thing. You put k plus k into 2 plus I here, k into 2 plus I here, and you open and open and open until you get everything in terms of k. And then in this case, you know your k can never be 0, because if k is 0, this thing does not exist. So the lowest value of k can be 1. Okay, so you have to take, because you're taking limit towards the lowest value, right? So the lowest value of k is 1. So you put, anywhere you see k, you put 1. So everything will still give you the same answer, minus 1 plus 6i. And I think it's interesting. Anybody, you see, evaluate the limit of this function as 1 plus 2. I mean, as z goes towards 1 plus 2i along the path A, parallel to the x, parallel to the x as coming from the right. You are going to plot it for me. B, I did not plot it for you. I plotted, okay, I did it for you. B, parallel to y axis coming from above. The line joining this point to the origin coming from where? From the origin. This one is coming from the origin. Okay? Always check this. I might say going to the origin, coming from the origin. Be very careful with this language. You know how to open this. This one, you have to put the value for z here. Have to put the value for z here. So one thing that you need to do for me when you go home, is not easy as you are seeing. Do your value of z, open the bracket, make sure that you do all these things and you get the same answer. Don't look at what I'm doing here. It's not really straightforward. Open your bracket, take your this term, multiply by this term, multiply by this term till you get this answer. When